Unit 1. This session would introduce you to the units of radioactivity. By the end of this session, you should be able to explain some units of radioactivity. Let us now look at units of radioactivity. Mass is very important in the study of radioactivity. It is used to indicate the amount of radioactive substance that is present per unit time. Now, one of the ways to report radioactivity is by reporting it in terms of the number of radioactive decays per second. So, how much of a radioactive substance that is consumed every second is the easiest way of reporting radioactivity. Let us now look at the units of radioactivity. We shall be looking at several units of radioactivity, but let's start with the becquerel, which is represented as BQ. It is one of the units of radioactivity, or for reporting radioactivity, and it reports radioactivity as 1 decay per second. Now, it's good to know that even in a small mass of radioactive material, there are thousands upon thousands of decays or disintegrations per every second. Another unit that we shall be looking at is the unit Curie, which is represented as Ci. Formerly, it was recorded with the reference of radium, and so it was recorded as the number of decays per second in 1 gram of radium. But currently, it is referred to as 3.1 times 10 to the power 10 decays per second. So every 1 unit Curie is equivalent to 3.7 times 10 to the power 10 decay per second. A typical example indicating how radioactivity is recorded is the amount of americium in an average smoke. Okay, so it can be reported at 0.9 microcurie. Some units that are used to represent or describe radioactivity give information about radioactive events occurring per unit time, or some also give information about the amount of radioactive substances that humans are exposed to. Another thing that I want you to know is the Curie is named after Polish scientist Marie Curie, who performed some of the initial investigations into radioactive phenomena in the early 1900s. The becquerel is named after Henry Becquerel, who discovered radioactivity in 1896. Also, both the becquerel and the Curie can be used in place of grams to describe the quantity of radioactive material. Let us look at this solved example. It says a sample of radium has an activity of 16.1 millicurie. If the half-life of radium is 1600 years, how long before the sample's activity is 1 millicurie? Now, the first thing we need to know in solving this question is that the half-life of the radium is 1600, which means that after every 1600 years, half of the amount of radium will decay, which means that after 1600 years, half of the amount of radium, which is 16 millicurie, will decay, and it should be left with half of it. Then after another 1600 years, whatever amount that we have remaining, that is the half that we have now, half of it will also decay, and it will be left with half. So we'll continue decaying half after every 1600 years till we get to 1 millicurie. So let's now go into the solution. So in the solution here, you realize that at the initial year, we have 16 millicuries as the activity. After 1600 years, half of that amount, half of the 16 millicurie will decay, so we'll be left with 8 millicuries. After another 1600 years, half of whatever amount that we have will decay. Now after another 1600 years, we will now be at 3200 years. That is 1600 plus 1600. So we will be at 3200 years. And half of what we have at 1600 years will decay. If we have 8 millicuries at 1600 years, then if half of it decay, we'll be left with 4 millicuries. After another 1600 years, which will make the total number of years 4800 years, that is the third year, half of what we have at 3200 years, that is after the second decay, will also decay. So if half of that one is decaying, we'll be having 2 millicuries. Then after another 1600 years, which is the fourth year, and it will bring the total number of years to 6400, half of what we have after the third year, that is 4800, will also decay. At 4800, we have 2 millicuries. So if half of it decay, we'll have 1 millicurie. This means that over a period of 4 half-lives, the activity of the radium will be halved 4 times, at which point its activity will be 1 millicurie. Thus, it takes 4 half-lives for the activity to decrease to 1 millicurie. The 4 half-lives are 1600, 3200, 4800, and 6400. Let us look at another example. In this example, they said a nuclide that has 26 protons and 33 neutrons is used to study blood chemistry. Write its nuclide symbol in the form of X, superscript A, subscript Z. Write 2 other ways to represent this nuclide. So the solution. The question says that there are 26 protons, which represent the number of atoms, that is the atomic number, and it's represented by Z. So in this case, Z is 26. And the question says the number of neutrons is 33. But we know that the mass number, which is A, is given by number of neutrons plus number of protons. So we sum them to get the mass number, which is represented by A, and the value is 59. The element or the atom with the atomic number 26 is iron, which has a symbol of Fe. So to represent this one, the notation given in the question we will have Fe superscript 59 subscript 26, and the two other forms is Fe superscript 59 or iron 59. Let us continue with the units of radioactivity. Other measures of radioactivity are based on the effect it has on living tissues. It either transfer energy like thermal energy from boiling water to tissues, and this can damage the tissues. Radioactivity can transfer energy to tissues in two ways. One of them is through the kinetic energy of the particles hitting the tissue. So radioactive particles hitting the tissue in a form will transfer energy to the tissue. Also through the electromagnetic energy of the gamma rays being absorbed by the tissue. So if the tissues absorb these gamma rays from these particles, they tend to get energy from them. So the RAD, which is an acronym for radiation absorbed dose, is a unit equivalent to 1 gram of tissue absorbing 0.1 joule. So we will say that every 1 rad is equivalent to 0.01 joule per gram. So that's the unit that is used to measure the amount of energy that the tissue is absorbing from the radioactive substances. Now this 1 rad, even if absorbed by the tissues, could be dangerous than you could ever imagine. For example, if we want to get an idea of the amount of energy this represents, you can consider the absorption of 1 rad by 70,000 grams of water. This 70,000 grams of water is approximately the same mass as a 150-pound person. This would increase the temperature of the person by only 0.002 degrees Celsius. And this may not seem like a lot, but it is enough energy to break about 1 times 10 to the power 21 molecule of carbon to carbon bonds in a person's body, and that amount of damage would not be desirable. Another unit of radiation absorption is the gray, which is represented by gene Y. So 1 gene Y or 1 gray is equivalent to 100, but the rads are used more for recording radiations absorbed by these tissues than the gray. It is also very important to know that it's very difficult to predict the effect of radiation on tissues. And this is because different types of emissions affect various tissues differently. To quantify the effect of these radioactive emissions on humans, we use the unit REM, which is an acronym for Röntgen Equivalent Man. It is defined as rad times factor. The factor is a number greater than 1 or equal to 1 that takes into account the type of radioactive emission that the tissue has come into contact with and the kind of tissue that has come into contact with the radioactive emission. So the factor for beta particles is 1 and the factor for alpha particle is 2. But if the factor for alpha particles is 10, if that alpha particle is coming into contact with eye tissues, then the factor is 30. Most radioactive emissions that people are exposed to are on the order of few dose millirems or even less, because when they are more than that, could be very effective. and very dangerous to the tissues. A medical X-ray, for example, is about 20 millirem. Another unit we can talk about the sievert, SV, and one sievert is equivalent to 100 rems. These are self-assessment questions. I'll urge you to go through them to prepare you for your quizzes and your exams.